बिस्मिल्लाहिर्रहमानिर्रहीम। अस्सलाम वालेकुम। आज हम एक नया टॉपिक शुरू कर रहे हैं, फटीग एंड क्रीप। पहले हम स्टार्ट कर लेते हैं फटीग फ्लेयर। व्हाट इज़ फटीग फ्लेयर? द डेफिनेशन इज इट इज़ द फ्लेयर ऑफ मटेरियल at stress less than the maximum value of stress under repeated or fluctuating load. Maximum value of stress means its value is less than the yield stress. Fatigue flare occurs over a long period of time. It means that the material failed after application of stress for a long period of time. The 90% of mechanical flare is due to fatigue. It means the maximum component structure or parts manufactured or failed due to fatigue. And it is more prominent in IC engines, aircrafts, compressors, pumps, etc. due to its working of these equipment in high temperature. The start of fatigue flare is due to internal cracks, holes or cavities, and then the cracks reaches the surface producing fracture of components. In case of fatigue, the stress may be tensile or compressive, and values may be range from minimum to maximum. Example of this is here. एक shaft है, supported at point A and B, length L. इसको अगर हम टॉर्क अप्लाई करें इस पे, और यहाँ पे जो है बेंडिंग लोड है, तो जब ये रोटेट होगा तो टॉप लेयर पे कंप्रेशन और लोअर लेयर पे टेंसाइल स्ट्रेस होगी। तो जब ये सेकंड साइकिल में जाएगा तो लोअर पोजीशन पे कंप्रेशन हो जाएगी और टॉप पे जो है टेंसाइल हो जाएगी। तो स्ट्रेसेस को हम इस तरह डिफाइन कर सकते हैं, सच साइकिल स्ट्रेसेस डेवलप्ड इन द मटेरियल आर कॉल्ड एज फटीग स्ट्रेसेस and corresponding flare will be called as fatigue flare. In this case, the stresses are reversed stresses. The graph of these stresses here on x-axis the number of cycles, and on y-axis stress value. This is sigma A stress amplitude or alternate stress, and this alternate stress is plus sign and this minus sign. This is tensile and this is compressive. Sigma R, the stress range, is equal to sigma maximum minus sigma minimum over 2, and sigma A, the alternate stress or the amplitude of stress, equal to sigma R over 2, and mean stress, in this case the fluctuating stresses, the stresses are this value of stresses are not equal. we can see here this positive tensile stress, the value is greater than this, the compressive stress. So stress value are different in this case, fluctuating stresses. So here mean stress, we can calculate mean stress sigma maximum plus sigma minimum over 2. The third type of stress cycles are the complicated stress cycle, or it can also be called random stress cycle. So this entire cycle is considered to be a tensile, and example of this is the aircraft wings are subjected to this type of cycle. Next, SN curve, the stress and number of cycle curve. In this case, the result of fatigue testing is plotted on a graph, is called as SN curve. It is a graph between stress and number of cycles plotted for fatigue loading. It means a material is subjected to alternate tensile and compressive stress at the same time, as we have already seen in reverse cycle. The result of fatigue testing is plotted on a graph, is called as an SN curve. Here there are two types of graph. The graph for mild steel, ferrous metals, and this graph is for aluminum, non-ferrous metals. And on this axis is bending stress sigma b in Newton per millimeter square, and on x-axis number of cycles of flare. So if we see this, in this case, if we decrease the stress, the number of cycle, decrease the stress, number of cycle will increase. Decrease stress, number of cycle will increase. In this case also, if you decrease the stresses, number of cycles increase. But in this case, in mild steel case, there is this point is a endurance limit or stress fatigue test limit. So for these two curves, we can define ferrous metal can operate at higher stress for less number of cycles, whereas non-ferrous metals can operate less amount of stress, less amount of stresses for more number of cycles. Less amount of stresses, more number of cycles. The stress amount is less as compared to this, but number of cycles is more. Here the stress is higher and number of cycle is less as compared to this aluminum or non-ferrous metals. Next, the endurance limit और endurance stress. If we see, अगर इस ग्राफ को हम देखें तो y एक्सिस पे स्ट्रेस और x एक्सिस पे नंबर ऑफ साइकिल्स हैं. अगर इसको हम यहाँ पे स्ट्रेस वैल्यूज यहाँ डिक्रीज हो रही है तो नंबर ऑफ साइकिल्स इंक्रीज हो रहे हैं. तो इस पॉइंट पे जाके ये इन स्ट्रेस लिमिट या सिग्मा ई पे जो है एंड्रेस स्ट्रेस इस पॉइंट को कहेंगे, और यहाँ से जो है इसकी लाइफ इनफाइनाइट हो जाती, स्टेट लाइन स्ट्रेट हो जाती है। और इसको फिर हम डिफाइन कर सकते हैं इस तरह, the endurance limit indicate the stress at which the material may be used for infinite number of cycles। यहाँ से इस पॉइंट से इधर इसकी लाइफ इंक्रीज हो जाती है इनफाइनाइट नंबर ऑफ साइकिल्स। सो वी कैन define it as, hence operating the material at endurance limit will increase its life। This is a type of loading, static loading and cyclic loading, explained in this diagram। The next topic is creep। The definition of creep is, it is a slow stress occurring in a material when it is subjected to high temperature for prolonged period of time। It means that flare is due to temperature or high period of time। It means that it's temperature dependent and also time dependent। In creep flare, material at a stress less than the maximum stress, it means that the stress flare at point as compared to the yield stress, its creep flare is at less stress than the yield stress। Creep is considered for designing of IC engine, boiler, steam turbine and gas turbine, etc. Creep is also a permanent deformation, means that it's deformed. When deformed, it cannot come to its original position, is permanently deformed। Hence, a special temperature resisting material must be used to avoid creep such as superalloys। इसका मतलब ये है कि जब हम इसको क्रीप को डिज़ाइन में कंसिडर करेंगे तो ऐसे मटेरियल्स यूज़ करेंगे फॉर इक्विपमेंट जो हाई टेम्परेचर रेजिस्टेंस हो, टू कंसिडर द creep flare। Creep mainly depends upon the temperature to which the material is subjected and the time up to which it is stressed। Here is a typical creep test is shown। This is curve between strain and time, strain as a function of time। तो यहाँ पे इसके 3 स्टेजेस हैं। स्टेज 1 इसको प्राइमरी स्टेज भी कहते हैं, स्टेज 2 इसको सेकेंडरी स्टेज, और स्टेज 3 इसको टर्शरी स्टेज भी कहते हैं। यहाँ पे जो है स्ट्रेन रेट जो है ये डिक्रीज़ हो रहा है, यहाँ से यहाँ कांस्टेंट स्ट्रेन रेट इज़ कांस्टेंट, और यहाँ से फिर जो है स्ट्रेन रेट इंक्रीज़ हो रहा है, और यहाँ जो है यहाँ पे आके ये मटेरियल कंप्लीट फ्रैक्चर हो जाता है। तो ये इसकी आगे एक एग्जांपल है जो इसको एक्सप्लेन करेगी, मज़ीद एक्सप्लेन करेगी। इफ़ेक्ट ऑफ टेम्परेचर का क्या इफेक्ट, क्रीप पे क्या इफेक्ट है। क्रीप इज़ हाई टेम्परेचर फिनोमेना। जब टेम्परेचर इंक्रीज़ होगा तो क्रीप की वैल्यू भी ज़्यादा होगी। यहाँ पे हम अगर हम देखें तो ये एग्जांपल्स है, एक स्प्रिंग मटेरियल है एल्युमिनियम, और एक स्प्रिंग मटेरियल है स्प्रिंग 1 में जो है स्प्रिंग मटेरियल एल्युमिनियम है, और स्प्रिंग 2 में जो है स्प्रिंग मटेरियल सॉलिड वायर और PVSN है। तो फर्स्ट के इस केस में जो है इसका मेल्टिंग टेम्परेचर 660, इसको कैलोन में कन्वर्ट करें 933 हो जाएगा। or a ratio between the room temperature and the melting temperature. 300 is room temperature divided by 933, the ratio will be 0.32. And in case of second spring, the melting temperature is 183 degrees centigrade. If we convert it into Kelvin, this value will be 456, and the ratio between the room temperature and the melting temperature is 0.66. So here we can see the creep is significant at temperature greater than 0.5 of melting temperature. So 0.66 in this second case, the creep will be higher as compared to in this aluminum case. This is for all for this lecture. Thank you.